Alright, hi you guys. Today we'll be talking about simplifying radicals. Okay, now you've known before that you can just put it in a calculator and get a simple radical. For example, you might plug in, let's say, the square root of 30. Okay, and so simply before you've just done this. Square root of 30, and you've get an approximation, which is going to be about 5.47722 dot dot dot. Okay, and it's not a pattern at all. It's actually a very irrational number. Well, today what I'm going to do is I'm going to teach you actually how to simplify radicals into a radical expression, and then we're also going to talk about rationalizing the denominator. Okay. All right, so first off, what we got to do is remember some key radicals to remember. And when I say radicals, I'm talking about square roots for right now, but you can apply this to later knowledge, especially in Algebra 2, when you're going over cube roots, fourth roots, and fifth roots. So right now we're just dealing with square roots. Okay, and these are all the key radicals to remember. Now, I know before that we've talked about, when we've talked about square roots, some of you guys are going, wait, hold on. For this one, the square root of 1 is 1. Isn't the square root of 1 also negative 1? Yes, it is, but for the sake of just simplicity, we're just going to work with the positives right now. We're just going to work with the positive answers. So technically, these all should have a plus or minus in front of them, but they don't, so here's where we're at. Okay, so some pretty simple ones. Square root of 1 is 1. All the way down to the square root of 169 is 13. Okay, now this will come in helpful. Why? Because of these two important properties right here, the properties of radicals, the multiplication and division property of radicals. Okay, so the multiplication property says if I have two numbers being multiplied under square root, I can simplify it by writing the first one under square root and then timesing that by the second one under square root, and you'll see why in a second. Okay, and you're probably already wondering, what do these have to do with that? And it has everything to do with that. Okay, all right, and then also division of radicals. If we are square rooting a fraction, we can square root the top of the fraction and square root the bottom of the fraction. Okay, and then deal with it fraction-wise. So that's going to be very helpful. Okay, so first off, 40. What we're going to do is we're going to do something called prime factorization. Prime factorization. And you probably wondered why you did this when you were younger. And this is exactly why. Is that what we're going to do is we're going to break this up. We're going to break up 40 into its prime factors. Okay, now you can delve up the prime factors any way you want. I usually start dividing by 2. Okay, just because I know that that's an even number. All right, and then I know that when I get to prime, I stop. But this is not prime, this is actually composite, so I'm just going to keep going with it. And so this is 2 times 10. Now some of you guys are going, well, why don't you write out 2 and 1? Well, 2 is already a prime number, so that's why I'm stopping. Okay, and I know that it does break down into 2 and 1, but we're not going to do that. So stop here, continue with the 10, so this is going to be 2 times 5. Okay, and if you notice, those are both primes. So we stop on both these accounts, and this is the really cool part. Okay, and this is going to equal 2 times 2 times 2 times 5. Okay, so I did the prime factorization. Now, if I look over here at this rule up here, I don't know the square root of 2 or square root of 2 or square root of 5. But if I put these two 2's together, that's actually square root of 4. So what I'm going to do is I'm going to rewrite this as 4 times 10. Okay. All right. Now this is one way of doing it. I like to think of it also a different way. So what I can do is rewrite this as the square root of 40. Well, it actually would be the square root of 4 times 10, which I can rewrite as the square root of 4 times the square root of 10. Okay, and as you can see, I'm running out a little bit of room, so I'm going to move some stuff over. So let's move this stuff over. There we go. Okay, well, here's the cool thing. I know the square root of 4, that's 2. So I can just change this to a 2, and I'm left with 2 root 10. Voila, I've simplified my radical. Now I don't know the square root of 10, so I leave it as is, and I just leave it as is. Okay, now another way to think about this is also the prisoners. For example, everyone's a prisoner inside. Let's get rid of that first. Okay, if you notice, I have two pairs of, or one pair of 2's, and they can break out of this prison because it actually has a square root. Okay. All right. So let's pretend that we didn't go all the way over here. Let's pretend we actually got rid of this. Okay. So I already have 2 guys that can break out. Okay. When you break out, you become one team. Okay. This is just a trick. It's not actually the most mathematical way to explain this. And so on the outside, I have 2, and then on the inside, I have 2 times 5. Okay. And that's on the inside of the prison. Now they're going to stay there until they can get partners later, so this will actually equal 2 root 10. Okay? And it's the same method as right here. So one way is an exact mathematical method way. The other way is a cool little trick that actually works, you know, pretty much all the time, what we're looking for, okay? All right, so the next one, 128. I'm going to pause and we're going to write this out. Okay, so 128 is 2 times 64. Now the reason why I stopped there is because I know the square root of 64, and that's going to be 8. So if I rewrite 128, so if I rewrite it over here, so this would be 2 times the square root of 64. This is definitely going to become, and I'm going to switch those around, 8 root 2. So I just switch places. So just switch places here. So that's the really cool thing about it, is that you can simplify it really fast by just seeing what you can do. And plus, if you divide by 2, you can also see a lot of cool stuff. Now here's the cool thing. For those of you guys wondering at home, this seems like this is going to be a complicated task all the time. Well, if you already know it in your head because you've done it in the past, like for example, if you see square root of 128 later on, you can simplify that to 8 root 2 whenever you want. Okay? All right, now 500. Now if you notice, there's already 5 out front, so I'm going to have the 5 out front, so it's going to be 500. I'm going to just break that down, and that's going to be 5 times 100. Now if you notice, I already have 100 as a square root. All right, so this is going to become 5 times, and I'm going to rearrange it, square root of 100 times the square root of 5. Okay, I already know the square root of 100 is 10, so this becomes 5 times 10, so that's 50 root 5. Okay, so remember, this turns into a 10, and I quickly times it by that. Okay, so that's some really cool stuff. Now what if I have some variables in there? Well, I still break it down, and I can still think about it, and you could actually add to this. So if you're ever seeing something like the square root of x squared, that will actually be x, because what times what is x squared? That's just x. Okay, so this will actually, let me see, 18, let's break that down. 18 is 2 times 9. Well, we know the square root of 9 is 3, so this will become 3 times the square root of 9 times the square root of 2 times, and you could actually break this down into 3 of these, x squared. Okay, now this right here is going to turn into 3, this is going to turn into x, and this just stays the same. Okay, so 3 times 3 is 9, x, and then you got the root 2, and voila, you've simplified it quite a bit. Okay, all right, now I'm going to speed, well, let's go ahead, 243. 243 is, now if you notice, that is not divisible by 2, so I need to think about this one. This is actually divisible by 9, and I believe it's 9 times, let me see, 243 divided by 9, 27. So it's 9 times 27, and if I break that down even further, I could actually go back and say, oh, that's 81 times 3. So it's totally up to you how you want to do it. Or you could say that is 9 times 9 times 3. It's totally up to you how you want to say it. Okay, but this one is going to be pretty ugly looking until I can actually write it off the side so it's not as compressed. Okay, so I've rewritten this out, okay? So this is going to turn into 3, this is going to turn into 3, this I don't know by using my list over here. Now, I'm going to apply the same logic I did with the square root of x squared is just x. Same thing here, so this will be just y, okay, and this will be x. Okay, and I don't know what this is, so I'm going to leave that there. So if you notice, I have two things in radicals, so I'm going to leave those together. And on the outside, I'm going to have negative 4 times 3 times 3 times y times x. And then we're going to have the square root of 3y. Okay? And that is definitely going to turn into negative 36 xy. And I just like putting it in alphabetical order, times 3, the square root of 3y. Okay, and that's the really cool thing about this is when we're working with this stuff, is that you can actually take something that's really complicated, and if you break it down into square roots, you can do that. Now, could I have taken these earlier and just did the square root of 81? Okay, and then change that to a 9? Yes, and as you can see, I would still get the same number of negative 36. Okay. All right, now square roots of this one, okay, of fractions, we're just square root the top and square root the bottom, and that becomes 4/5. So it's as simple as that. Okay. All right, now working with something like this problem right here, the second problem of it, you're still going to have the 15, okay? But on the top, you're going to break that down. So we're going to treat this as two separate fractions. So I'm going to break down 84. That is, what is that, 42? 2 times 42, which is the same as 2 times 2 times 21, which is also the same as 2 times 2 times 3 times 7. Okay, now if you notice I have two 2's there, so I can change that just to a 4. And I definitely know the square root of 4, so that's going to be 2 root 21 on the top. And then on the bottom, I'm just going to have 4. Okay, now if you notice, I do have a 2 and a 4, one on the top, one on the bottom, so I can simplify those into root 21 over 2. Okay, and as a matter of fact, I can just go ahead and get rid of the parentheses, okay, and just treat it as is. So the way this would actually look, let's go ahead and cut this. Okay, let's add. All right, I can get rid of the parentheses and just have this be 15 root 21 over 2. Now, if 15 and 2 both shared a common factor, I'd definitely reduce that. Okay, now rationalizing, okay, is pretty simple. If you have something on the bottom, just go ahead and multiply top and bottom by it. The same thing. So let's go to the next page real fast just to show. All right, so in order to get rid of the radical on the bottom, I'm going to multiply by the same radical on top and bottom. So I'm going to actually multiply by it. So that's going to be the square root of 11. And then I'm going to do the same thing. So times by the square root of 11. All right, and what happens is on the bottom, that's going to turn into square root of 121, which we all know is just going to be, oops, just over 11. Now, some of you guys want to reduce this. Please don't. Please do not. So this is just going to turn into 11, okay? That's outside the radical, that's inside. All right, on this one, we would just times by root 7 on top and bottom. And it's a great old trick that actually works all the time. All right, and so what I actually get is not a different fraction, but the same fraction just rationalized in the denominator. So it's going to be root 21 on top, and then on the bottom is going to be 7. And do not simplify. One's inside the radical, one's out. I'm going to show you this step really fast. Okay, now I've simplified the bottom because 242 is equal to 121 times 2. Okay, so that becomes 11 root 2. All right, now on top and bottom, instead of multiplying by root 242, I'm just going to multiply by root 2 on top and bottom. Okay, and then I'm also going to, at the same time, going to simplify 22 over 11 and get 2 root 2 over 2, which if you notice, I can also simplify again and just get the square root of 2. All right, that's it for simplifying radical expressions. I will talk to you later. Bye.